This is Dr. Sajja Suneel from Data Science Department. Today I am here to discuss with you about Module 5 overview, which is Introduction to IoT Physical Service and Cloud Offering, guys. This was the best thing which we need to know. Why? Because what are the different kinds of cloud offerings was there, and what are the different kinds of IoT physical servers which are existed, how these physical servers and cloud offerings are supporting our IoT system, so that we'll have a good knowledge on these principles of IoT, guys. Let me tell you what exactly these things are in a form of overview. Have a look, guys, very carefully along with me. This class is going to be very good. Have a look. What are the topics which I am going to discuss in this today's class? The things are, I am going to let you know what are the different kinds of storage models, what are the different kinds of communication APIs, and what are the different kinds of web servers and cloud for API, and what kind of web application framework, what kind of design I have did for RESTful API. These are the topics which I am going to discuss with you today. Have a look. What IoT physical servers, cloud offering, and IoT case studies are. First, before discussing about this particular topic, what are the objectives and what are the outcomes which we are going to get after successful completion of this particular class was. The first IoT objective, this particular class of about physical servers, cloud offering, and IoT case studies are, we are going to understand the roles of these particular things in detail. We are going to explore different kinds of services which are offered by cloud. We are going to analyze different kinds of case studies, and finally we are developing a good IoT ecosystem with the help of these particular things, where includes both hardware as well as software as well as cloud infrastructures. What are the outcomes which we are going to grab after successful completion of this class? We are getting the ability to select an appropriate hardware. We are getting skill for designing and implementing a good IoT projects. We are getting knowledge on industry best practices. We are improving our capacity to evaluate and propose IoT solutions for different industry verticals. What are the different kinds of IoT physical servers? In IoT physical servers, there are three different types of IoT physical servers. The core function of this particular physical server was, it was a on-ground hardware component which is going to serve you as a backbone for your IoT network, guys. What a physical IoT server was? IoT physical server was on-ground hardware component. If I am implementing a physical server, means I am placing a server in my particular office, which is going to support you, which is going to act you as a backbone, guys. What are the different types of servers? Edge servers, which are located closer to the IoT devices. Gateway servers, which are connected to IoT to network for providing security. Data center servers, which are very powerful and which is very large scale storage purposes. And what exactly cloud offerings are, right? What exactly cloud offerings are? Here, cloud is going to provide us a very flexible and scalable computing resources to handle the IoT applications. Cloud is going to provide three different kinds of services: IaaS, infrastructure as a service; PaaS, platform as a service; and SaaS, software as a service. These are the three different kinds of services which are provided by the cloud. We will discuss it with these services in detail along with the diagram in the coming slides also. Have a look. What cloud offerings are? See, IaaS, PaaS, SaaS. I already told you. IaaS, which offers virtual, I have clearly specified which will be helpful to you for your study. IaaS, infrastructure as a service, which offers virtual service, provides flexibility suitable for organizing. Examples are AWS EC2, virtual machines, and Google Cloud. PaaS, platform as a service, which provides a development and deployment platform for IoT applications, focus on application development and management, suitable for developer and without extensive IoT resources. The best examples: AWS IoT Core, Azure IoT Hub. And coming to SAS, software as a service, where we are going to deliver complete IoT solutions as a service, require minimal IoT intervention, and additional cloud services are IoT device management, data analytics, machine learning, security. These are the things. Coming to the case studies, which shows you the real world scenario of applications where we are providing valuable insights to the successful IoT implementations, challenges, business impact, industry inheritance. Have a look. What are the common IoT case studies which are well known to us? Smart cities, smart health, agriculture, manufacturing, retail. These are the IoT case study areas which are very common nowadays. And coming to the cloud storage models, I already told you this is going to refer different kinds of methods for storing the data on remote service. Coming to communication API, these are the set of programming instructions which allows us to perform on different kinds of software applications to interact with each other, guys. And coming to the cloud storage models, web server for IoT, cloud for IoT, Python web application, web server, a software application that handles the HTTP request and serves static or dynamic content. The best example was Apache Nignix IAS. Coming to web server IoT, it is specifically designed or configured to handle the unique requirement. Cloud for IoT, which is going to refer cloud services tailored for IoT and Python application framework. It is a software framework which provides a structure for building web applications using Python programming language. The best examples are Django, Flask, or Pyramid, guys. And how we are going to design a RESTful web API. We are defining a RESTful API by using HTTP methods like get, post, put, delete. These are the four methods. Designing a RESTful API, which involves developing API endpoints, HTTP methods, request and response formats, error handling. Coming to essential topics which are used for robust IoT system, where we are storage, holding IoT data and communicate the things. And coming to communication API, MQTT, which is message queue telemetry transport, HTTP, hypertext transfer protocol, COAP, constant application protocol, AMQP, advanced message queuing protocol. These are the different kinds of communication protocols which are used for facilitating the coming to communication APIs, WebSockets, RESTful APIs are facing a major role. What a cloud storage was. Basically, cloud storage is a service model for enabling multiple things such as on-demand network. The main important point was on-demand network access to a shared pool of computing resources such as network, servers, storage, application, etc. What was the core concept? Here, the purely we are storing the data and retrieving whenever we required. That was the core concept, guys. Key benefits: accessibility, scalability, cost effectiveness, data redundancy. And how it is going to work. Data is going to be uploaded, data is going to be retrieved. What are the types? Public cloud, private cloud, hybrid cloud. Public cloud stands for accessible to anyone. The best examples: Amazon SC3. Advantages is scalability, disadvantages security concern, guys. And coming to the next one, private cloud, which is a dedicated single organization. Here the advantages is we are having greater control, the disadvantage is high cost. Coming to hybrid control, which is a combination of both public and private. And the challenges: management complexity, data consistency. Community cloud, which is shared by multiple organizations with similar needs. Like example, industry specific clouds. Cost sharing is the advantage. Disadvantage: only limited control will be there. And what are the different kinds of cloud storage models? Object storage, block storage, file storage. These are the three different kinds of storage models which are existed. What are the key considerations? We need to consider the data type, we need to consider the access pattern, we need to consider the performance requirements such as cost, scalability, and security and compliances. These are the things. How to need to understand it in a different ways. Object storage, this is how the things are. Data is going to be stored in form of objects with metadata, right? And coming to files, block storage, data is going to be stored in form of block of raw data. Here there are just examples: Amazon EBS, that is what block storage. Coming to file storage, Here data is stored in hierarchical structure similar to old traditional models like files and folders. The best example, Amazon EFS, Google File Store, etc. Choosing a correct storage model depends on you guys. Why? Because we need to consider multiple factors by choosing a data. Why? What those are? What data type was? What access pattern it has? What performance requirements it has? What cost it has? What scalability it has? And what kind of security and compliances we are maintaining. Coming to example, object storage, storing website content comes under object storage. Running databases, which comes under block storage. File storage, sharing files among multiple users comes under file storage. These are the best example use cases. What a cloud storage was. Cloud storage is a service model where we are enabling unambiguous and convenient on-demand network access to a shared pool of computing resources, guys. And this was the cloud architecture, basic architecture, how the things are going to work. Here the data, user, workflow, vendor specific, infrastructure, cloud layer, hardware layer. These are the different kinds of layers which are presented in cloud. And coming to types of cloud storages, as I told you, public cloud, private cloud, hybrid cloud, community cloud. These are the only four different types of cloud storages which are existed in any kind of cloud offerings, cloud manager, right? Have a look. Private cloud storage, which is going to be very secure and scalable and great usage control, expensive, suitable for large enterprises. Public cloud storage, which is easily scalable, affordable, reliable, sensing, zero maintenance, suitable for individual users. Hybrid, which is easy for customization, affordable, and greater user control, secure and scalable, suitable for mid and small size companies. Coming to community storage, where we are using secure, affordable, scalable, suitable. These are the things which are there in these different types of cloud storage. I already told you about three different storage models: object storage, block storage, file storage. And coming to the things which are represented by considering these three models, I have represented this table for your better understanding, guys. This table will be a good, useful. Take a screenshot, and this is very helpful by considering multiple factors such as types of storage, how much volume of data will be maintained in these models, how we are maintaining the data, and how what was the cost, what was the performance, what was the scalability, and how it is ideal. These are the three, seven different kinds of factors which I consider for representing in these three models of storage: object, block, and file. These are the use cases. Cloud storage use cases: data backup and recovery and disaster recovery, archiving, and big data analytics, data storage and processing, scalability and cost effectiveness, content delivery, fast content distribution, scalability, and it is very cost effective, guys. And coming to the application development and testing, different kinds of development environments are, different kinds of testing and development is there, different kinds of collaborations is going to be happen. Collaboration and file sharing, they are having shared access, version control, accessibility. These are the different kinds of collaborations which are going to be happen. What are the other use cases which are used? Image and video hosting, e-commerce, online gaming, IoT data storage, DevOps. What are the security and privacy consideration? Important data encryption, access control, permission, data redundancy, and compliance regulations. These are the things. And what kind of digital symphony will be implemented in APIs and web servers? Application programming interface, which is essential for setting multiple rules and protocols, which allows a particular software application to communicate with each other, right? And what are the different types of APIs? RESTful API, SOAP API, GraphQL API, WebSocket API. These are the four different types of APIs which are existed. RESTful API, SOAP API, GraphQL API, WebSocket API. These are the four APIs which are existed, guys. What was the use of web server? Web server is a computer programming where that server web pages to the user is going to be respond. Got it, guys? Popular Apache. You can take it, right? What was the powerful combination of these two? The powerful combination was API driven development, microservices architecture, real time implementation, integration. These are the things which are going to be happen. What is an API? I already told you, it is a set of definitions and protocol. The types I already specified, and What kind of things are going to be used in RESTful API, which is a REST means representational state transfer, which is an architecture style for designing network applications, guys. And coming to the web servers, software which handles the HTTP requests and servers static or dynamic content. Here, web servers, reverse proxies, API gateways, server-side, example architecture, RESTful API design guidelines, resource-based URL, HTTP, API documentation, API security. And coming to the next one, web server technologies, comparison of Apache, Nginx, IAS, these are the things. And coming to API testing and debugging, importance of API testing, testing tool, debugging techniques, these are the things. And coming to API security, there are commonly vulnerable security best practices. API security was there. What was the two powerful things, API and web server? I already told you in previous thing. These are the modern applications which are used for interplay, for request handlings, response gathering, data delivery. Now I will show you a visual representation. Web request response cycle. This was the front end which I am showing here was the front end. In the front end, being as a client, you are going to browse something. In the back end, the web server is going to send request to web browser is going to send request to the web server. There the business logic function will send information to storage. Again from storage the information will be taken back and this web server is going to send back information to web browser. Client is going to view it on the client screen. This is how web request response cycle is going to function. And what was the importance in API design? The blueprint for success was you need to know the developer experience, what kind of consistency, what kind of flexibility, what kind of performance, and what kind of documentation was he preparing. And also multiple assets are there. And coming to graphical QL, this was the future enhancing for data fetching. Why? Because here client driven data fetching, improved performance, enhancing experience, real time updates are going to be there in this GraphQL. Coming to microservice architecture, which is used for decoupling services, scalability, resilience, technology, heterogeneity. These are the factors. Coming to API economy, we are improving revenue generation, ecosystem, competitive advantages, and partnership is here. And what was the convergence of trends? GraphQL and microservices, API economy and microservices, API economy and GraphQL. These are the web servers. We need to understand a particular web server by improving the IoT content in specialized software applications which acts between bridge as IoT devices and the digital world. It is going to collect and process the data and communicate with you guys. This is how a web server is going to look like. Key characteristics for this web server in IoT was real-time processing, scalability, security, latency, and resource efficient. These are the things which are existed. And coming to the different types, embedded web servers, cloud-based web servers, edge servers. And coming to the challenges, data volume, data format, security threats, real-time processing. These are the challenges which I am facing in a web server. Coming to cloud for IoT. Till now we discussed web for IoT. Now cloud for IoT. Cloud for IoT is a comprehensive platform which enables the connection of management and analysis of IoT and data, where we are providing infrastructure and the remaining things will be taken care of. The core components for this cloud offerings are device management, data ingestion, data storage, data processing, application establishment, security. These are the three things which we are facing. What are the benefits? Scalability, cost efficiency, global reach, rapid development, data management, security. And coming to the cloud for IoT, what are the popular clouds for IoT was AWS IoT Cursor, AWS IoT Hub, IBM Watson IoT. And coming to Python Web Application Framework, we need to understand the exact role of this Python Web Application Framework was. Why? Because this was a framework which is a collection of modules and tools which provides structure for developing web applications or services, guys. That is what the beauty of this framework was. The key features are routing, templating, data integration, session management, form handling, and security features. These are the key features in this Python framework. And coming to popular frameworks, Django, Flask, Pyramid, I already told you in starting itself. And coming to other frameworks, Bottle, Tornado, Fast API, we need to choose a proper framework by based on your project size and complexity. What kind of performance needs are, what kind of team expertise was, what kind of features are there in our project. These are the factors which we need to choose at proper choosing framework. And now, what kind of integration will be there? Data collection, visualization, device control, API ends. And coming to understanding RESTful APIs, there are key principles as resources, stateless, catchability, uniform interface, layer system, code on demand. These are the things. Designing RESTful API. Identify resources, define URLs, choose HTTP methods like get, post, patch, delete, and design responses like JSON, XML, and data representation purpose. And this is how to design a RESTful API by implementing error handling, to know about the version, to give security, and to prepare a proper documentation. What are the best practices for designing this? You need to maintain consistency, and it should be in a simple format, and the performance factor will be secured, and usability will be very easy. That's it, guys. This is about IoT physical service and cloud offering techniques which are there in our particular course called Principles of IoT. Thank you. We'll meet in the next class.
Like, share, and subscribe. Hit the bell icon for more updates.